In an earlier video, I was 3D printing some replacement log loads for these log wagons. So I thought I'd give you a quick update on how the project is progressing. I've printed and painted in. These are rather too large. That's more of a scale. But these are, I think, Thurn models. I've also done one slightly longer for the Atlas pulpwood carrier. But then, looking at the other wagons I've got, a while ago I bought some of these Evemodel flat wagons, and I thought, well, yeah, it'd be nice to have some logs on there. So I extended the length of the log load, and there we are. Oh, hang on, there's something missing. So I also printed a set of ends. I can remove these little bits of string. A set of ends. And printed some of them up. So hopefully, when I get around to it, I can glue that onto the top of the flat wagon, and there we have a slightly longer than prototypical log load. And there's another Evemodel flatbed wagon, and there's a slightly different style of end for the logs. Now these ones, the original ones, I was printing in white PLA and then painting brown, and these ones I've actually printed them in a brown PLA and painted the ends with just a white wash to lighten them up a bit to represent the cut ends. I'm not sure. Maybe I should tone down these logs. They do look a bit shiny. We'll see. So okay, so that's it for basically the progress on so far. Again, as I say, if you've got this far, thank you for watching. The second half of this video will be not so much how to print the log loads, because I've covered that in the previous video, but how I go about printing these adapters, and why I bothered printing the flat bits. Okay, well, if you've got this far, thank you very much for watching, and I'll see you later. Cheers. So here we are with OpenSCAD again, and this is one of the more complicated. This is the more complicated of the two adapters for the Evemodel to allow it to take the log load. I've gone a bit overboard with the bolts on this one. Let's have a look at the other one actually, because that's a bit simpler. but it'll do as an example of how I go about developing these shapes using OpenSCAD. Let me start by looking at the end pieces here. The edge is a fairly complicated shape. It's rectangular at the bottom with a bit of a wedge on top, and doesn't show terribly well here, but there's a recess of the same shape. So in order to get that, what I've done is I've declared a module, which is the OpenSCAD equivalent of other programming languages, subroutines or functions or whatever. So basically it's a piece of code that I want to reuse later on. And I've called it wedge. I'm using the OpenSCAD function, built-in function hull. Now what it does is it accepts three shapes or a number of shapes as parameters. If I highlight them, so I've declared a little line here, a little cube here, a little cube here, and a smaller one up here. And what the hull function tries to do is it draws the outline of those shapes that you give it. And that's how, in this case, how I end up with a square at the bottom and a wedge-shaped quadrilateral on top. If I clear those again. And then in order to get the recess in there, what I've done is I've declared I've used this piece of code down here using the difference function. And what the difference does is it takes one shape. In this case, it's the original wedge shape that I've declared, and it subtracts another shape, or you could give it a number of shapes, and it subtracts them from the original shape. In this case, what I've done is I've declared another wedge, which is slightly smaller and slightly up above. So here we have the original wedge shape, and I'm subtracting the smaller one from it. So that just gives me, just hollows out the end of the side of the thing. And then what I've done is put in a few more cross members and verticals. If I highlight them in red, they just form the end of the adapter. I know the whole thing's called a wagon, but I don't know what you would call this end part of the wagon. I'm just going to call it an adapter or an end for now. So if I take those highlights off again, and again, I'm using the OpenSCAD module to declare a module called a side. And again, I can what I'm actually doing is I'm cheating. If I highlight one side on here, you can see that I've only ever declared half of the wagon adapter. But OpenSCAD has quite a nice facility which is really handy for any shapes that are symmetrical, called mirror. And well, you can guess what that does. In this case, it'll take three parameters. A 1 in the X position gives you a mirror in the X axis, Y axis, and Z axis. So if I swap those over, the highlight is on the new part. So you only have to. So for relatively complicated shapes that are symmetrical, you really only need to declare half of it, and then you can use the mirror function to fill in the rest for you. Software engineers tend to be nice and lazy, so we like to get the computer to do stuff for us. Right, so that declares a module end, and obviously this this adapter has two ends. And again, I'm using the mirror because the mirror function because well, this one is facing the other. And they're both facing inwards to hold the logs in place. And then finally, what I've done is to just generate a couple of little lines along the length of the adapter. First of all, to keep these in place, and secondly, to help me just measure out the length of the wagon. So and again, I'm using the difference function here. So I'm declaring a cube, which is basically the bottom base of the module. Sorry, of the adapter, and then I'm subtracting a slightly smaller cube from that, which basically just hollows out the middle. You could leave it full, but you know, it costs more to print and it takes longer to print. The other thing I've done is I've declared the length as a variable, as any good software engineer would. And so you can just adjust the length of the wagon by changing that value. Can't go too crazy because the Evemodel is about the largest length that I can print on my printer. So you have to consider certain practical realities. And that's it. As I say, the other one is very similar. Again, I'm declaring. There's a bit more code in these ends, but again, I'm taking the same approach. Each of these vertical items these fins is declared as a module, and then I'm simply having an array of 4 of them with a solid backing plate, and then declaring that as a module, and then instantiating that one there, and a mirror image copy of it There. I really do like pulpwood SCAD. It's nice for generating simple things, simple shapes, but even complicated parts that are made up of simple shapes. I wouldn't go and use it for building, D&D miniatures or anything with a flowing um, soft shape or anything. Nice regular shapes. It's very good at. Sorry, organic is the word I'm looking for. I wouldn't try to produce any sort of organic trees. Any sort of organic shapes with it. I wouldn't try to model trees with it, for example. I'm blethering on now. So if you've got this far, thank you very much for watching this. I'm going to try and see if I can do some more 3D modeling of useful things. All the best. Thank you. Bye.